Hey everybody, I've got the second part here of our file input-output chapter. We're going to be working with binary files. That's what we did in the first part was working with text-based files where you could actually open it up and you could see the text in it, like those ASCII characters. The difference with a binary file is that you can't open it up and see anything interesting in it. So if I were to, let's see, probably just yeah. Let me just open this up here. And if I were to put like a Microsoft Word file in here, let's see, yeah, here's a Word document, test, and we'll just put some gibberish in here. Just put test and save it. This file, notice docx, that's just the file extension. Again, it's completely arbitrary. It just tells Windows that when I double click it, it should open it with Microsoft Word. If I were to try and open this with Notepad, we get gibberish, right? This is binary content here. So the data in here has very specific meaning to Microsoft Word, and it knows how to read it, looking for specific things in specific locations. So you can see that there is some of it that looks a little bit like English in places, but most of it is just nonsense to us. Doc props, sure. There's a couple places here that you might see something, but that's a binary file. So it's made to be read and written to by a specific application. So what we're going to do is we're going to look at how we can write binary files ourselves. So again, we're going to use fstream. We include fstream so that we can get the ifstream, ofstream for input and output. And then we're going to use just the regular fstream, and we can give it some arguments on how we want to be dealing with our files. And you can actually have a file open for reading and writing at the same time. As crazy as that sounds, it can work. It's not my favorite option, but it's definitely fast if you're going to be modifying that file a lot. So let's start with a stream. Let's just call this our file stream here. And then let's open one up. So we're going to call open, and let's just call it, I don't know, sample.dat. Now, again, the extension is just, sure, it's whatever it is here. It's helpful if I can spell that right. We're just calling it .dat. Sure, it's a data file, right? It has some data inside of it. And then what we want to do here is we give it a comma, and we need to give it a couple things. So we use this iOS prefix for input and output. I forget what the S is at the moment. And then we tell it, hey, this is a binary type file. So this is telling it, hey, we're going to read and write to it using binary information. Then you do a single pipe. That's the shift \. So this pipe is actually the bit combination, I want to say, in C++. And it's escaping me at the moment. And what we do is we tell it iOS, either we read or we, here we go, for in or out, whether or not this is an input file or an output file. So if we're going to read a file, or in this case we're going to write a file here, we want to use the out flag. So this has a particular meaning here. But they just kind of combine them all together. It's really cool how this works. And it means something to file stream open, or fstream open. Right, so we've opened the file, it's going to create it, and then we can go write something to it. So my file stream. Now this is where it gets really weird. You have all sorts of fun stuff that we need to do to write to it. But what we're doing is we're going to give it a memory address and tell it how many bytes to write. And this is why it's kind of a little bit more complex than just, hey, here's a string or an integer and output it. So let's say we were to make some set of values. Maybe we have int numbers, size 5 or so. And then let's just give it some values right now. So 1, 2, 4, 8, and 16. How about that? So give it some values. Now what we're going to do is we're going to call write. So my file stream.write. And what we need is this constant pointer to a character. And again, it's really the memory address. I'm not really sure why they deal with it as characters, but what you can do is you can do this conversion. Implicit, there we go, implicit convert. No, that's not it. I will just grab it out of here. Mr. Gaddis has it for us. Reinterpret cast. There we go. We say, hey, reinterpret cast this thing as a character pointer, and what we give it is my numbers array. Okay, so we're telling it, hey, really, this is, remember, an array is really just a memory address, essentially. So we're saying, here's a pointer to the memory address, and we're just going to call it some characters for whatever reason we do that. Again, this is sort of a mystery, but that's okay. And we tell it, well, how many bytes do we need to write? So I'm going to tell it, or how many bytes are we going to read from here and write to the file? So we want to write the size of numbers. And then when we're done, we close it. File stream.close. That's all we're going to do. So this one's not super exciting. We're just going to write some data to a file, and then we should see a sample.dat file get created. It didn't crash, which is good news. So we take a look in here, we have sample.dat, and again, if we try and open this, say with, oh, there's an open with, Notepad. Yes, Notepad, why did it look like it didn't work? It looks like gibberish, right? It's meaningless to us because it's not text. It's not written as text. Okay, so I'm actually going to comment this out for now. It's Control-E, Control-C if you like keyboard shortcuts. I'm going to repeat the process for reading something in. I'm going to declare an int numbers, size 5. And I'm not going to give it any values this time. And then we're going to grab this file stream here, sample.dat, and this time it's iOS in because we want to read here. Should read that line too, sorry. And now I'm going to call file stream.read, and I have to give it, where am I reading this to? So when I'm reading, so when I write, I say, where are you starting? Where's the memory address? What are we going to write? When I read, it's where am I going to read to? So again, it's this reinterpret cast thing of numbers. So this is the location where I'm going to be reading the data into memory, into my numbers variable. And then how much do I want to do? I want to do size of numbers. So read that many bytes. And really, each integer is 4 bytes, so 4 times 5 is going to read 20 bytes. You could put 20 in here, but get into the habit of using size of. It's much more proper. And we'll just see out numbers, say at 0. Oh, let's loop through, right? Why not? So for int number in numbers, let's see out number and an end line. Sure. So let's see if we can read the file, right? And then when we're done with it, make sure you close it. So open, read, write, and close. Always those 3 things. And 1, 2, 4, 8, 16. I got it out. Awesome. So now the problem is if we don't match this up quite right, if I were to say this was size 6, and I try and read from that file, I get garbage because there was not a good value there, right? Didn't work very well. Or maybe if I do size 4 and I'm reading too many bytes into that location. Oh, well, it didn't crash on me, but I missed something here. So you need to be careful when you're reading and writing. Now, if you do want to read or write a single piece of data, so if you don't want to write an array, you don't have a variable that's essentially a memory address, what you need to do is you're going to use the address of that single variable, right? So that's the ampersand. So hey, I want the address of this thing. And we'll do that in just a minute here with some other sample binary stuff. So this is all well and good, but again, it's sort of silly to be storing just a bunch of numbers in this format. We could do this exactly in text. Where this gets to be a little bit more useful is you can make structs. So let's say we'll call this a struct for maybe person, and person maybe has a string for name, and maybe they have a, I don't know, an int for age maybe. Now the problem we're going to run into, remember strings are actually objects, and what an object stores is the memory reference. So when we're dealing with binary files, we don't get to use strings, which sucks. But what we can do as a nice alternative is we can use a character array, and it's just going to be a fixed size, say 30. So every person will have up to 30 characters in their name, no more, no less. Right? You might not have to use all of them, but we're going to allocate that space. And sure, we can do that. So I'm going to just leave this commented if you guys don't mind. Just leave that out for now. So what I can do is I can make a new person, like Eric, and then I can say Eric.name is equal to, and now here's where it gets silly. I can't set the character array to a string, right? If I put Eric in here, it's going to be upset with me. What I can do is I can use a cool library, which is my string copy. And you want to use string copy S for safe. It gets upset with you if you don't. So I want to copy. So string copy, string copy S says, okay, where is it going to go to? I'm going to copy it to eric.name. And where's it coming from? Well, it's going to come from eric. Oh, I'm sorry, I need a string first. So we have a string for name equals Eric, and then I can take name.cstring. So strings in C++ have a handy function called cstring because we have to do this nasty conversion back and forth often enough that gives you a character array. So the string class is great and wonderful. We can do good things with it in C++, but remember we still kind of want to support those old C strings, which is just a character array. And it turns out when we are dealing with binary data, you don't want to use strings anyway. You want to use character arrays. So we need to go back to this nasty format. But string copy will make a copy from here to here. Really nice and easy. You don't even have to loop and do it yourself, which is awesome. And then I want to say like eric.age, we'll set that to 33. So now I've got the struct. Now if I want to write that to a file, right, I'm going to say, all right, a fstream, this is binary data file.dat, sure, why not? Nope, binary data file, sorry. And then binary data file.open, we'll call this, I don't know, eric.dat maybe, because it's going to have my info in it. And then we need to tell it that it's going to be a binary file. And then we want to tell it with that pipe character again that I want to write, or out. We're going to output data to that file. Okay, now I can actually write it. So now what I can do is I can take my binary data and I can call write, and I give it this reinterpret cast thing again, which is really silly, but that's what we do. And I give it my object, Eric. And then, well, how much am I going to write? I'm going to write the size of Eric. However many bytes that is, sure, do it. Now this is where we run into the problem again. Remember, this here is not a memory address, right, like an array was. So what I need is I need to reinterpret cast as a character pointer the address of Eric, and I'll write the size of Eric bytes. I'll take my binary data file and I'll close it. So this is going to write just this instance's data, just Eric's data, to that file. Let's give it a run. We should see now we get an eric.dat in a second. So there's an eric.dat. Again, it's gibberish. Sure, that's fine. So let's comment this out again for a minute. And let's see if we can read the data. So we're going to make a person Eric from file. And then we're going to create an fstream for my binary data file, and we're going to open it with eric.dat. We need to tell it it's a binary file, but this time we want to do for iOS in. We're going to read the data in, okay, and then we're going to call read. So binary data file.read, and what are we reading to? What's the location? Well, I want to read it to the reinterpret cast character of the address of Eric from file. So again, still doing this reinterpret cast of the character pointer, and we're going to send it to the address of Eric from file. And how many bytes? Well, size of Eric from file, right? That many bytes, however big that is. Okay, and then we're going to close it. We always read, open it, read or write, and close. Make sure you always do those three things, super important. And then just for fun, let's see out, we'll do Eric from file.name and colon, sure, why not, and Eric from file.age. And that line, we'll see if we can get that information back out from this eric.dat file. And it looks like we did, Eric, age 33. Okay, so that's using singular pieces of information there. Again, let's comment that out for now. Now the next fun thing we can do is we can use an array of structs. So I can have a bunch of these pieces of information, and then you're actually able to navigate around the file byte by byte to say, hey, maybe I don't want to read all 100 all at once, or all 1,000 or all 10,000 all at once. Maybe I want to be able to jump around my file here. And that's where it gets to be really interesting. Again, you can make sort of like a fake little database. It's obviously not as good as a real database, but we can do that sort of thing. And that's something we're going to be doing for our final project, because it's good practice to do some of this binary file in and out, and to learn how that sort of works and how we can navigate around the files. All right, so we're going to make a person array. We'll just call this people of size, I don't know, we'll do 10 or so. Again, these sizes need to be fixed because we're not using dynamic memory. And then if we are using pointers, it gets confused when we write stuff, because the value of a pointer is actually the memory address, and we want the thing that's actually stored at that address. So usually we'll just have fixed values here, just to not have to deal with that headache. Anyway, so we got a list of people, and maybe we'll get some information. So I don't know, let's do init for number of people. Starts off at 0, and we're going to say while number of people is less than 10, I can keep getting more information. But we might also want to be able to stop this loop at some point. So I'm going to make a string for name, and then I'll say cout, enter a name, or quit to stop. And then maybe we can cin name. And we'll say, okay, if as long as we're less than 10, and name does not equal quit. Right, then we can keep on going. So once we got a name, great, we're good. And we're going to do this again at the end, but then we need to get an age. So let's see out here the age of the name. Then we can see in, we need an int for age. We can see an age. Great. And then we can make that into a people object. So we're going to take people at index of number of people dot name, and we need to, again, we can't just assign it the string because this is a character array. So we're going to do our string copy safe to here from name to cstring, and then my people at number of people dot age is the age. That one I can just set, and then I can take my number of people plus plus. So we're going to get their age. Sorry, we're going to ask for a new name after. So we'll get their name. Then as long as we have room, right, because it's a fixed number here, and they haven't told me to quit, we'll get their age, and then we'll assign it here. This unassigned is fine. We're okay because we declared it. We've got all 10 out there. We just have garbage values right now. We're just overwriting. So let's copy the name to the character array, and then we'll set the age, and we have all of them. Then I can start writing it to file. So I'll take another F stream. This will be my binary array data, F stream, my binary array data dot open, and let's open, say, I don't know, people.dat maybe, as a iOS binary file, and we want to write to it. So that's out, iOS out. Then we're going to write to that file. Now, we also might want to tell someone how many people we actually have in this file. So what I'm going to do first is I'm going to write the reinterpret cast of type character pointer of the address of number of people. And I need to write the size of number of people. Right, one more parentheses. There we go. So I'm going to write that number first so that whoever reads my file knows how many people I actually have written to my file. Then I'm going to write, with this reinterpret cast as the character pointer, my people array. That entire array gets written, and it's the size of people. Right, however big that array is. So whatever I had sized it to before, here, right, my people array, great. It's going to write that many bytes to there, and I'll close it. Binary array data dot close. Okay, so we're going to try and write some data to our file. See if we can write an entire array worth of data. All right, so we'll write Eric, age 33, and then maybe I'll have my son Jeb, he's 13. I'll add Beatty, she's 11. Joy, she's 19. Journey, she's 10. Jubilee just turned 9 today, actually. And another name. Did I get them all? Oh, Jackson. He is 6. And I think I got them all. Okay, so I got me and the kids added. So that should be 7 people so far. Again, that people.dat file is gibberish. Right? If I try and open it with Notepad, don't always want to try that. It's okay. Oh, look, I actually do see some values here. It's not completely gibberish yet. That's nice. So we do see a little bit of text. Cool. So let's try and read it. Right, so I'm gonna ignore all this reading stuff for now, if you guys don't mind. Let's comment all that out. So I kept my people array and I kept the number of people. So I'm gonna make an F stream. This is my binary array data to read, or something like that. Sure, binary array data to read. .open. This is people.dat. This is a type of binary file. And we want to iOS in. We're going to input the data. Nope, not curly braces. I got excited. Semicolon. All right, so then the first thing we're going to do is we're going to read the number of people, because I know that comes first in the file. So my binary array data dot read, and where am I going to read it to? I need to reinterpret cast of type character pointer of the address of number of people. And I'm going to read the size of number of people. And it's just an int. Okay, then I can read right of my people array, which is already size 10, and the size of. Now this one is a little bit trickier. Now I can read all of it, and I'll get some garbage data that I'm going to read out, or I can be specific and say, hey, I only want to read the size of a person times the number of people bytes. So tell me however big that person struct is, read as many people as I'm supposed to have out of it. I mean, both ways we're going to have lots of stuff there. A wider type to avoid an overflow. Oh boy, okay, sure. I think we'll be okay because we're not using too much memory. So either way, we're going to get some weird results because we don't actually have all of that data populated. Right? It said it was size 10, we didn't actually have 10 there. So either way should be okay for you. If I know how many I'm supposed to read, I'm just going to be specific and read that many. The problem is I can't make that array to be the right size. It has to be oversized, so I'm using an array and it's constant. We're not using the dynamic memory. So let's give that a try. See, and then maybe we'll see out. Oh, here, let's do this. We'll do for person in people. See out person.name, colon, and person.age, and an end line. We'll see if we can read them all out. Cool, so I get Eric, Jeb, Vivi, Journey, Joy, Journey, Jubilee, Jacket. I got them out of order. And then I get the garbage values. Ooh, so I don't actually want to do for person in person here, because I got those garbage values, and I don't want the garbage values. So what I want is I want an int index at 0, index is less than number of people, index plus plus, and I want to read out people at index name. Okay, so this will only get the valid ones that I actually have placed data in. Okay, now I get the good looking data there. Life is good. So just, yeah, that's cool. So a couple other things you could do while you're reading and writing, some other fun stuff. If we want that random access file, right, we don't have to read everything at once. So if you've got a large database, this is silly, but if I had, maybe all the students at OCC and I wanted to track their grades and their classes and all that other sorts of stuff, I probably don't want to read all of that into memory at once because I probably don't have room for it. But what I could do is I could read just a portion of the file if I know where they're going to be in the file. So we use some sort of index tracker. Usually like you'll do something with their ID number and you'll use that to say, okay, if your ID number is this will be your index in the file, that sort of thing. And we got options for that, and we can talk more about that another time. But that's the basics of reading and writing our data using the binary format. And a couple things here. If you're doing a single object, you need the address of it. If you're using an array, that variable really already is an address, like we've seen before. So you should be fine there. You're going to open, you're going to read or write, and you're going to close. You can pass both in and out. And we will look at some examples of that next time. where we can keep the file open for read and write mode, so I don't need to be jumping around and closing it and writing it and closing it. That's one option. In our cases, we're just reading the data here. But maybe if we're to make like our own silly pretend database, and we could go in and edit things on the fly and write them to the file, we could do some fun stuff with that. So we'll look forward to that in the group project. All right, sorry this one was late. Turns out YouTube was actually having some trouble as well, so that the timing wasn't too bad. But I'm going to head back now. I'll get this one uploaded, and I'll catch you guys around. Please do ask me questions in Discord. We can go from there. You guys take care.